Okay, this video will go over everything that you need to know for your quiz on rational functions next time we meet. So, I'm going to get started. It is basically bringing everything together that we have covered in the last week on rational functions. So, number one says sketch the asymptotes and graph the functions, then give the domain of each function. So first off, when you look at this function, we've talked about it and hopefully you know by now that down here where my denominator is equal to 0 is where I'm going to have a vertical asymptote, and this number over here is where I'm going to have a horizontal asymptote. So I'm going to draw those. I have, well, that is not it right there, because your line, I'm glad it did that. Okay, make sure that your line is dotted. It is not part of your graph, so it should not be solid. It's not part of the equation. It is just lines that assist your graphing. Okay, so we have that. Now, what is a little bit new now is that we have a number here. What you've had before, or what we've talked about previously, is we had key points -1, -1, 1, 1. We had 2, 1/2, and 1/2, 2. Okay, those are our key points. If this number is 1, I want you to plot those points, and you know that they're in opposite quadrants. But if this number is 5, you can actually take this point. I hope you realize that this 5 is up top, not down here with the x, so it's affecting the y, which means that instead of having the point 1, 1, I now have the point 1, 5. So from the intersection of my asymptotes, I can go over 1 and up 5. 1, 2, 3, 4, 5. That's the vertical stretch that's going on. And then the nice thing about it, so I have the point 1, 5, and then every time you graph it, you can just take that point and switch it. So you're really only having to worry about changing one point. So I have 1, 5, and now I'm going to go 5, 1, which I think, yeah, that's right here. Okay, and then we know it's in opposite quadrants, so I'm going to do the same thing. I'm going to go left 1 and down 5. 1, 2, 3, 4. Okay, I don't think I counted that right. 1, 2, 3, 4. 1, 2, 3. Okay, there we go, right here. And then if I go down 1, 1, 2, 3, 4, 5, or over 5, down 1. Okay? And then do your best to connect those. Let's see what I can do to make that look, approach your asymptotes. Okay? So hopefully y'all will do better at that, at connecting. Oh golly, that's really bad. Let's try that. Definitely do better with pencil and paper. Alright, and that's all you got to do. Okay, let's look at the next one. The next one says y equals -4 over x plus 2 minus 3. Oh, wait. Forgot the domain. So what is the domain? I think y'all are pretty good at that. This is the only point that it can't be, and that is x equal to 1. So y'all know that we go -infinity to 1, union 1 to infinity. Okay, now on to the next one. Again, bottom number, denominator equal to 0. X is going to be -2 is my vertical asymptote. Y is equal to -3 is my horizontal asymptote, and you always want to start with graphing those. So I'm going to cut here. That makes so much sense. X equals -2 here. Okay. Now, again, I don't have a 1, so instead of having the point 1, 1 from our key points over here, I'm now going to have the point 1, -4. So when I normally went 1 over 1 up 1, I'm going to go over 1 down 4. And I hope you can see that that negative is flipping it. So down 1 over 4, or 1, 2, 3, 4, 1. Okay, and then I'm going to do the same thing because I know it's in opposite quadrants. So I'm going to go over 1, 1, 2, 3, 4. And then I'm going to go over 4, 1, 2, 3, 4, up 1. And this, remember, is all in relation to the new intersection of our asymptotes. And again, hopefully y'all can do a better job of drawing that. Okay? So, a little bit easier than finding all those key points. I hope you think that. All right, and so again, our domain, -infinity all the way to this vertical asymptote, which is -2, union -2 to infinity. Okay, this next problem. This one says write an equation for the translation of y equals 4 to the x with these asymptotes. Okay, so basically, y'all, I'm telling you that what the asymptotes are. So you're given this, and you have to give me that. So I hope you realize or can see that this is y equals 4 over x. That says x equals 7, and if x equals 7, we know that that's going to be minus. So it's x minus 7, and then plus 6. Okay, moving along. Number 4. Okay, this says describe the vertical asymptotes. Okay, so I want to refer, and holes. Okay, and this is something from the first lesson that we covered on this unit. Okay, but let me refer you back to this chart that I gave you. Okay, and that is domain. We know where the denominator is not equal to 0. Okay, we've just done that. I don't think you'll have any trouble with that. But then we have a hole and a vertical asymptote. And these both have to do when you're about your denominator being 0, or but one of the things that you need to remember is you want to find that hole first. And a hole comes when a factor cancels. So when I look back at this problem right here, y equals x minus 3, x minus 1 over x minus 1, x minus 5, I hope y'all can see that this factor cancels. So that factor cancels, x minus 1 equals 0, and that means that x equals 1. So I actually have a hole at 1. Now how do I find the other part of that hole? What does it say? It says plug into reduced form. So that means that I'm going to go back, and what do I have left here is x minus 3 over x minus 4. Excuse me, x minus 5. That's your reduced form. So when I plug it in, y is going to be equal to 1 minus 3 over 1 minus 5. 1 minus 3, of course, is negative 2. 1 minus 5 is negative 4. And when you simplify that, you get 1 half. So we have a hole in our graph at 1 comma 1 half. Okay, now the other thing, so look back here. So that's how you find the hole. That's what that means. So hopefully when you see that, it will ring a bell. Now, your vertical asymptote, you look at what's left in the denominator, and that can't be 0. And your vertical asymptote should always be x equals some number. So when I go back to my problem, okay, what's left in my denominator is right here. And so I think y'all are good, but x minus 5 equals 0. So that, of course, means x equals 5. And that is our vertical asymptote. Okay? All right, look at the next one. It says describe the vertical asymptotes and holes for the graph. Same kind of problem. The only difference is you got to do a little work and factor. So the top is already factored enough, but the bottom becomes x plus 4, x plus 2. Okay, we're looking for those factors of 8 that add to give me 6. So that's what we got. Now, none of these factors, no factor cancels. So if there's no factor that cancels, then you don't have any holes in your graph. Okay, and my vertical asymptotes, again, are coming from where my denominator is equal to 0. What makes it 0? And that, of course, is x equal to negative 4 or negative 2. Okay? Okay, horizontal asymptote. Now, if we go back to our little chart and look at horizontal asymptote, which was the end behavior, okay? We talked about it as end behavior because we found more than just the horizontal asymptote. We had the horizontal, but we also had one that was a line and one that was a parabola. And the end behavior asymptote can always be found by quotient, giving you the quotient after you do long division of your rational function. However, sometimes you don't have to do all that work, so they're nice little Betsy, Bobo, Botu to help you figure it out without doing that work. Okay, so what does this mean? It's talking about the degree of your function. What is the degree of, and actually it's the degree of the numerator and the degree of the denominator. So when I go back to this problem, we're going to go look and see the degree is the highest exponent that you see. So on this problem, what is the degree of the top is 1, and the degree of the bottom is 2. The highest exponent is a 1 right here. That's the highest exponent. So you look at the degree of each part of your rational function. And then Betsy says, if the bottom equals the top, that's your bet, bottom equals top, then you use the coefficients. Okay, on our problem, was the bottom equal to top? It was not. Okay, Bobo, is it bigger on the bottom? Was ours bigger on the bottom? It is bigger on the bottom. Okay, so if it's bigger on the bottom, bo, that's what that O means. It actually stands for 0. And if it is bigger on the bottom, then your horizontal asymptote is y equals 0. Okay, so then we go to the next one. Since I've done that one, let's go ahead and go to this next one. What is the degree of the top? Or actually, let me write this outside so you can go back and look at that. And remember, this is Bobo. Okay, and now we have y equals 3x minus 4 over 4x plus 1. The degree of my top is 1. The degree of my bottom is 1. So hopefully you see that the bottom equals the top. That's Betsy. Okay, and so when you look back here, what does the C mean? It says coefficients. Okay, that is the leading coefficients. And so what you're looking at, if you've got those, is these are your leading coefficients. So my horizontal asymptote here is y equals 3/4. Okay, and the next one, the degree of my top is 3, and the degree of my bottom is 2. And so that, of course, means it's Betsy Bobo Bo 2. So this is bigger on top. And we have a U. And what that U tells you is it stands for undefined to help you remember that it doesn't have a horizontal asymptote. And that would be the example, excuse me, that would be the example where we found a slant asymptote or a parabola that was an asymptote and behavior asymptote. But what's important is it's not a horizontal one. Okay, so these are answering the questions of just whether or not you have horizontal asymptotes on your graph. Okay, turn your papers over. The graph of this function is a translation of y equals 4 to the x. What is the equation for the function? Okay, this is just like this problem right here, but the difference is I didn't tell you the asymptotes. You have to go find them from the graph. So if we go look at what they are from our graph, this crosses at -4, so I have x equals -4. And this would be a great way to show me your work when you're working these in case you mess up. And y is equal to 3. Okay, so that means that my function should be y equals, you've got to give it to me as a variation of that, 4 over x minus -4 gives me plus. It's always minus, so it's the opposite of what it looks like. And then this is the same, so that's going to be plus 3. Okay, same thing on this one. The graph of this function is a translation of y equals 2 to the x. So I'm looking at my x, and it looks like it goes through at 5. And I'm looking at my y, and it looks like it's going through at -3. So my function is going to be y equals 2, because it's a variation of this guy, over x minus 5 plus minus 3, because the y does the same thing. Okay? All right. Now you have to sketch the asymptotes and graph the function. And this was the other rational function that we talked about. And keep in mind, if you forget, it is up here at the top. This is 1 over x, and this is 1 over x squared. Okay? Um, so our asymptotes, if you remember, all right, we have x equals 0 and y equals 0. So I'm going to go ahead and graph those. X equals 0. If you don't have this, which I'm sure y'all don't have this lovely tool to draw your asymptotes, it's always a good idea to just label them because it's hard to read when you're taking a quiz or doing the problem. Okay, so these are your asymptotes. The other thing that we had were our key points here. We had -1, 1, and 1, 1, so we knew this one was basically symmetric. And then we talked about the point, if it was 1/2, then we knew that it went up to 4 because it went up faster, excuse me. Okay, so in this problem though, I have a 3 up top, and so when that 3, how does that affect it? If I put a 1 in here, okay, that 3 is affecting my y, so it's changing my y value here. So at 1/2, what do I have? I have 1. No, but now I have 3 because I changed it. So it goes 1, 2, 3. Now, at 1/2 instead of 4, what do I have? I have 12, so it's gone up that much faster. But another point is if you put in down here to test a point, you can put in 3 for x. So if I put in 3, What's 3 over 3 squared? Well, that's 3 over 9, which is 1/3. So 1, 2, 3. I'm just going to put that point. And again, it mirrors. Now let's pause for a second. Okay, so we'll keep going there. So then we find it on one side. We know that it mirrors on the other side. And 1, 2, 3. And so I've got this. Like I said, it's going a little bit, it's increasing at a faster rate than the one we had before. Okay? All right, look at this one. Y equals 1 over x squared minus 2. All right, what's happening here? It's that same parent function, so we have these points, but what's happened here? I still have x equals 0, but that, of course, has shifted it down to y equals 2. So in this case, let's go draw our asymptotes again. X equals 0, and y equals, I said 2, and y'all know what I mean. It's supposed to be, and that's not the pen, so let's take that off and make it with a pen. Y equals negative 2, and go back and try to draw that asymptote. He says, wait, there's y equals 2. Okay, and then we'll use our key points. It's just 1 over, so we just get to plot it. Okay, so at 1, I have 1. And at 1/2, we had 4. 1, 2, 3, 4. Those were the key points that we talked about. And if you want to do that other one, we knew that 2, it was 1/4, because we're just taking the reciprocal of that number. And so that's enough to do it. Okay? All right, last two problems. Graph each rational function. So you're looking at it and you kind of got to figure out what to do. Okay? Um, you can quickly find out the horizontal and vertical asymptotes by what we just did earlier. But I want to point out, if we do what we have done previously while we've studied this and do the quotient, do the long division, then it makes the plotting of your points easier. So in this case, I'm going to come over here and divide. Remember, we talked about toppling that guy over, so we know that x minus 2 is on the outside and 3x minus 1 is on the inside. What do I multiply x by to get 3x? And that, of course, is 3. And so I have 3 times x is 3x, and 3 times negative 2 is not negative 2. It is negative 6. And so I subtract this, and I end up with negative 1 plus 6, which is 5. Okay, and that's kind of an important number because that's what's helping us not have to plot a bunch of points. So when we write this as a sum, remember this is y equals, we always start with the quotient, plus the remainder over the divisor. Okay, from here I have an vertical axis of x equals 2 and a horizontal axis of y equals 3. So I'm going to go plot those. X equals 2 and y equals 3. So we have this. And now um, there's that 5 on there. If it was a 1, you could just plot those points we talked about. 1, 1, and then we did 1/2, 2, and 2, 1/2. But there's a 5 there. So remember, my 1, 1 point becomes 1, 5. And so if I go over 1, I'm going to go up 5. 1, 2, 3, 4. I'm up there. I'll move this guy out of the way. See if I can move him. Go up. Go away. Come on. Move. Okay, I didn't get the 3. Let's move the 3. There we go. All right, so when I plot him, I'm going to go over 1, up 5. And I'm going to go over 5, up 1. And looking like that. Really bad. And then over here, I'm going to go 1, 2, 3, 4. I'm counting the wrong thing. 1, 2, 3, 4, 5, 1. And 1, 1, 2, 3, 4, 5. And boom. Okay, getting pretty bad. All right, if you want to check it, we didn't talk much about intercepts on this, and I regret that. But if you want to check, you can always check intercepts and see if your graph is good. All right, last problem. Um, we got a bigger mess than that over there, so I don't really want to do that long division. I'm going to hope that my teacher's going to give me something that factors. So this bottom factors as x minus 3, x plus 3, and the top factors to x minus 3, x minus 1. So these cancel. So I'm hoping y'all remember that ding, ding, ding. A factor that cancels back over here that we talked about is a hole. Okay? So you actually have a hole in your graph. So where is my hole? My hole is at 3 because I'm taking x minus 3 and setting it equal to 0. Okay? X equals 3. And where's the other part? Remember it says to plug it into the reduced form. So that means that y equals 3 minus 1 over 3 plus 3, which is 3 minus 1 is 2, and 3 plus 3 is 6, so it's 1/3. So the whole is at 3 1/3, and all you got to do is go graph that. So we go 1, 2, 3, and I go up 1/3. And what you're going to do is you're going to make a circle, okay, so that we know that it actually doesn't connect at that point. Okay, so I'm left with x minus 1 over x plus 3. So I need to go divide that. I know that x plus 3 is on the outside. X minus 1 goes in one time, leaving me with x plus 3. And when I subtract, then negative 1 minus 3 is negative 4. Okay, so my sum, if I write this as a sum, is going to be the quotient, which is 1, plus, you can write plus and put the negative 4 up here, or you can write minus 4. But this will help you remember that it's going to flip over the divisor. Okay, so from here we know that this is a horizontal asymptote. This is my vertical asymptote. Pause. And we're back. Nope, pause. Okay, let's hope those interruptions are over. Alright, so I think I'm at plotting the asymptotes. X equals negative 3, 1, 2, 3, so we're here. And y equals 1. Okay, still have my hole right here. And then what are we left with? Negative 4. So that point of 1, 1, when I went over 1, up 1, now becomes 1, negative 4. So instead of going over 1, up 1, I'm going to go over 1, down 4. 1, 2, 3, 4. Which means that I would go over 1, 2, 3, 4, and down 1. Now the nice thing about that, notice that that's going to connect right with that hole. So that lets us know that we are, and so when you come to the hole, you just get right to it, and then go to the other side of it. And then of course on the opposite, we're going to go over 1, up 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 1. And do your best to make that look like what we've been graphing. There you go. So, so that sums up the review practice quiz for rational functions. I hope that simplified the process for you. If you have any questions, please come see me or email me.